remains entire arc. And if I say that we substitute t equal to 0, okay, so I'm allowed to substitute t equal to 0. So what would be p prime of 0? So we're going to have 0, 0. Okay. So we're going to get 0, 0 actually. So what you're going to say? The path is not regular at the origin. And can you see it why? Imagine something is moving in this way. So it's going down and then going up again. So it's going down and going up again. He has no other choice to stop here. Because in order to go up, you have to stop. You can't just, you're going down and then, without, and going up at the same time. If you are going down, so you're going down, the particle is going down, stopped here and went up actually. And what is the meaning of stopping? Velocity is 0. Velocity is 0. So it's not a regular curve actually. And the rest of the points is going to be regular. Okay? You're going to take all of the points except the origin, the cusp space. Whenever you are solving a problem in exercise sheet, okay, it's always good that open your GeoGebra or maybe your whatever tools that you are using and plot the thing that you are talking about, and then you will realize that the kind of complicated things that you are dealing with. And the good thing about the beauty of the mathematics is that you can even investigate a function when you are not looking at it. Think about it. Can't I just talk about the differentiability and continuity of a function which I have never saw actually? You can still talk about it. That's what the beauty and the power that mathematics gives, is that it allows you to do things very abstract. Okay? Is it making sense? Shall I move these guys? How far they go? Better this to use that path. Okay, now let's define a curve now. So what's a curve? So you just have to check, whether you are getting, the derivative evaluated at that point 0 or not actually. There is no. Yes. Okay, the kink is creating the trouble.
सर अगर हमारी एक वैल्यू 0 है दूसरी नहीं है तो फिर
क्या मतलब?
यहाँ पे हमें x axis में 0 मिला हुआ है.
Then you're going to treat it as a non-zero vector. It's not a zero vector. So when I'm saying this, that's a very good point. That's a very good point. When I'm saying that p prime of t naught is not 0, that 0 is not a real number but a 0. That's a zero vector actually. So I know that a vector is not 0 if any one of its component is not 0. So we are happy with the regularity of a curve actually. So is it okay? Can you all guys can see this? Okay? You all see this? So now I'm defining a curve. So what do you think? What should be the definition of a curve? So what should be the definition of a curve?
A regular path.
Okay, regular path. So not just the path, but the image set of the path actually. In other words, P of t is one point, but when you combine all these points and put them together, you get a curve actually. It's a very natural way. Okay? So definition, a parametric curve. Every single word has an importance. So you don't have to neglect the things. You have to, when you're calling a curve, For example, when I am calling a curve, make sure every component is continuous. If it is not, okay, it could be anything, but it's not a path actually, mathematically, okay, the way we are defining it. So a parametric curve are simply a curve. So whenever I'm going to say curve, you know what really we're going to mean a parametric curve, okay, is a subset C of Rn. So it's a subset. So if you have a curve in R3, okay, it's really like a subset in R3 actually. Why? Because what you are doing is that, you know, out of all the points of this space, you are choosing some points and, you know, combining them to get a curve actually. Okay. The question is, how can I get this C? What do you think? What should be the definition of the C? Okay. So the C, so it's a subset C of Rn, okay, such that together with the path, so you need to have, whenever you have a curve, you're going to have a path P that is a map from I to Rn such that, okay, such that this C is basically the image of the entire interval. Okay? Because if you have a path that is throwing every single point from this interval into Rn, and what is going to be the meaning of P of I? The collection of the all outputs that we can have. So it's an image set of the P, and this image set is going to be a subset in Rn, and you call that image set as a curve. It's a very natural way to define it. There can't be any other way to define it actually. It's a very natural way to define it. Okay? So whenever we are going to talk about a curve, or you are going to talk about a curve, you know its path, it's a subset in Rn, or a subset in R3 or R2, but that subset, you are getting that subset because of a path actually. Okay? That subset is basically image of a path. Okay? So whenever you have a curve, you also always going to have a path whose image set is the curve actually. Okay? Are you getting the point? So whenever you are talking of a curve, okay, if I'm defining something on a curve actually, you have to always ask, okay, what is the path corresponding to that curve actually, or what is the path that defines that curve? Okay, that is going to be an interesting thing. Okay, so there are some more conditions.
So can curve be in one dimension? Can curve exist in one dimension?
Curves can exist in one dimension. Think about it. How does the curve would look like in one dimension? So it's going to be the map from R to R actually. Okay, so you're kind of throwing one part of the real line onto some other part of the line. So interval to interval, maybe some subset of R to subset of R. The curve would not be interesting in R actually. We can define it, obviously you can take n equal to 1 and hence you have curve in R, but you also need, okay. By the way, definition is not over. The parametric curve is simply a curve, is a subset C of R together with a path such that C of P equal to I, and this P, the path that you have, in addition, it satisfies some more properties. In addition, P satisfies, so it must be a path, but what kind of a path? Okay. Number one, P must be regular. Okay. P, if I say that P is piecewise continuous. is continuous, and the second condition that it must satisfy is that P is regular. Okay? So in other words, it's regular on I. Okay? What is the meaning of regularity? That P prime of T is not zero for any T in the I actually. Okay? So your path can be piecewise continuous. Okay. What do you mean by piecewise continuity? So like this is piecewise continuous. So you have two pieces you have put together and it's a continuity. You can also treat this as a continuous function, but if I see, I can also see this as a piecewise continuous function. So if I want to turn this curve the curve that you have, if you want to turn it into a regular curve, what you need to do? So you have to remove this controversial part at this point. So you have to remove the origin from the domain. You have to remove 0 from the interval I actually. And once you're going to remove this 0, this origin is no more going to be a part of the curve. And now you don't have a continuous curve, but a piecewise continuous curve, because you have two pieces, so the curve reaches and ends before the origin and starts right after the origin actually. Okay. So you have a piecewise continuous. Okay. So here's a mathematical thinking question. So if I have what do you say? So if I have a set of all continuous functions and I have a set of all piecewise continuous functions, which set is a bigger set?
Continuous.
So in other words, I'm asking, is every continuous function is piecewise continuous, or every piecewise function is continuous? A piecewise continuous function is continuous. Every continuous is? Every piecewise continuous need not to be. So which set is bigger? Set of continuous functions or set of?
Both are equal. सर ये दो पर्सपेक्टिव दिमाग में आ रहे हैं। एक तो हमारा सबसेट होगा देना था इंफिनिटी एक वो में बुझा रहा है, अगर वो हम साइड कर दे तो फिर हमने पढ़ा था नेचुरल नंबर और
forget about that. Just think in your head actually.
सर जो पीसवाइज कंटीन्यूअस फंक्शन होंगे वो सबसेट नहीं होंगे कंटीन्यूअस फंक्शन
सर
जो कंटीन्यूअस हैं और पीसवाइज कंटीन्यूअस तो पीसवाइज कंटीन्यूअस
So a continuous function is a continuous function that has only one piece actually. Think about it. So I have a continuous function on an interval. Okay, so I can treat that entire continuous function as just one piece. And I can take such pieces and put together and I can get. So now which set is bigger? Thank God you got it. Okay, so the piecewise continuity is a more relaxed condition actually. Okay, is a more relaxed condition. It's a more weaker condition, while the continuity is a stronger condition. So when you are developing a theory or you are developing a theorem or you are developing a mathematics, you try to keep your assumptions more and more relaxed. So if I, for example, from this, if I say remove this assumption, okay, remove this assumption, that means that my theory, the theory that I am building, okay, is going to be valid for only continuous functions actually. But now you are accommodating a lot of other continuous function actually. So continuous function is also piecewise continuous because it's single piece actually. It's a single piece. It's just a one piece of a wire. Okay. So a parametric curve is a subset of Rn together with a path, and you can see Phi as a P of the image set of R. Okay. And in addition, this P, in order to be a correct parametric curve, must be at least piecewise continuous, okay, and it must be regular. Okay. So if it has all these properties, we are talking about a parametric curve. From that cusp, if you get rid of the origin, everything is fine. You have no problem. जी
सर पाथ की डेफिनेशन है कि वो कंटिन्यूस होगा सर।
हाँ।
अगर हम कोई पॉइंट इससे मतलब ले रहे हैं, जीरो नहीं इंक्लूड कर रहे हैं, तो वो कंटिन्यूस तो नहीं रहेगा ना? उस पॉइंट में नहीं होगा सर।
उस पॉइंट
सर,
पर
क्योंकि-
बट स्टिल यू कैन हैव कंटिन्यूटी।
सर यहाँ से अगर जीरो निकाल लेंगे सर रियल नंबर से, तो ये डिसकंटिन्यूस हो जाएगा जीरो में सर उस पॉइंट।
So I'm saying that the domain of the function is not r but r minus 0.
ठीक है।
So if you even remove the 0 from the domain, then there is no problem actually. Problem would be that the question of discontinuity would come if the 0 is inside the domain actually. ठीक है? Okay. I mean, in the previous chapter, there was one thing that I didn't talk about, and I really don't like the way, the book talks about it, but, maybe you can keep it in your head. So, in the previous chapter, about the differentiability, says a function is smooth if it is continuous and differentiable. Okay, so it's a continuously differentiable. It's of the C1 class, so it's continuous and differentiable. Okay. No, I mean yes, a function is continuous, so function may be Rn to a scalar field or a vector field, whatever. Okay. It's smooth if it is continuous and differentiable. While I don't like this definition. Why? Because for me smoothness is infinite differentiability. In other words, it's a kind of a function to which you can differentiate it as much as time you like actually. Okay. But that's what this guy is defining actually. Okay. But, I mean, if you see implicitly what he is assuming here, as per his definition of smoothness, that your path must be smooth actually, because you have continuity and differentiability actually. It's talking about the smoothness of it.
Sir,
But forget about it.